Have you ever imagined drawing something and then, poof, it becomes a real thing you can hold? That's kind of what 3D printing is all about. It's like magic, but it's science. We're talking about building objects not by carving them out of a big block, but by adding material, one tiny layer at a time. Think of it like a super precise robot building with digital Lego bricks. It starts with nothing and builds up your design from scratch. The core principle is called additive manufacturing. Traditional ways of making things, like milling or lathing, are often subtractive. You start with a block of wood or metal, and you cut bits away until you get the shape you want. Additive manufacturing is the opposite. It adds material, plastics, metals, ceramics, you name it, layer upon tiny layer following the digital instructions. Nothing is wasted unnecessarily, which is just brilliant. This technology didn't just appear overnight, of course. It started quietly, in labs, with clever people tinkering away. For a long time it was a specialist tool, a bit slow, a bit expensive. But the promise it held, the sheer potential to revolutionize how we design, create, and even repair things was enormous. In the early days, 3D printers were mostly found in research labs or the design departments of big companies. They were pretty chunky machines, often quite slow, and the materials you could use were a bit limited. Their main job back then was something called rapid prototyping. Imagine you're an engineer designing a new part for a car. You'd want to see if it fits, right? Or if it feels right in your hand. Before 3D printing, making a model might mean complicated hand carving or setting up expensive tooling just for one test piece. With a 3D printer you could have a physical model in hours, or maybe a day. These early models weren't always super strong, but they were perfect for checking shapes and sizes. Then things started to change, and fast. The machines themselves got more sophisticated. They became faster, more reliable, and crucially, much more affordable. At the same time, scientists and engineers were developing all sorts of new materials that could be 3D printed. This was a huge leap. One of the most brilliant things about 3D printing is the sheer speed of it, especially when you're developing something new. Imagine you've got a design on your computer. With traditional methods, turning that into a physical thing could take weeks, even months, if you need special tools or molds made. With 3D printing, you can send that file to the printer and, depending on the size and complexity, have a part in your hands the same day or the next. This rapid turnaround is incredible for innovation. Another massive plus point is how much less wasteful it is. Many traditional manufacturing processes are like that. They subtract material. But 3D printing, being additive, only uses the material it needs to build the object. There's very little waste, which is not only good for your wallet, but it's also much kinder to our planet. Less mess, less waste. That's a win-win. This unlocks a whole new world of possibilities for engineers and artists alike. Your imagination is the main limit. It makes things personal. That incredible speed we talked about doesn't just mean getting one part quickly. It supercharges the whole design and manufacturing process. If you can print a new version of your design every day, you can test it, find problems, and make improvements much faster. This iterative process, trying things out and refining them, is at the heart of all good engineering and design. 3D printing makes this cycle spin so much quicker, leading to better products developed in less time. That's a massive boost to overall efficiency. Now think about warehouses. Big buildings full of shelves, stacked high with spare parts for everything imaginable. With 3D printing, the idea of digital inventory is becoming a reality. Instead of storing physical parts, you store the digital file. If a customer needs a spare part, even for an old product, you can just print it on demand. This is revolutionary for inventory management and reducing obsolescence. Personalization is another area where 3D printing truly shines. It's making production more responsive to what people actually want, which is incredibly smart. Section 5. Wild Shapes and Wonder Materials, Designing the Impossible. One of the things that still makes my jaw drop about 3D printing is its ability to create incredibly complex geometries. We can design and print intricate internal lattice structures which make parts incredibly strong yet surprisingly lightweight. These complex shapes aren't just for show, they offer real performance benefits. By using these optimized, lightweight structures created through 3D printing, engineers can design parts that are just as strong or even stronger than their solid counterparts, but weigh a fraction. It's engineering art, really, creating strength and lightness where it's needed most. And it's not just about the shapes, it's also about the incredible range of new materials we can now print with. This combination of complex geometries and advanced materials allows for truly unique designs that are optimized for their specific function. It's a designer's dream come true, really. Section 6, 3D printing all around us. Cool examples everywhere. Let's look at where this amazing tech is making a real difference. Take aerospace, for instance. Building rockets and airplanes is all about making things strong but incredibly light. 3D printing is perfect for this. Companies are printing fuel nozzles for rocket engines, brackets for satellites, and all sorts of interior components for aircraft. Even astronauts on the International Space Station have a 3D printer to make tools and spare parts on demand. The automotive industry is another big fan. For years, car makers have used 3D printing to make prototypes of new car designs super quickly. But now, they're also using it to print custom tools, jigs, and fixtures for their assembly lines, making the manufacturing process smoother and more efficient. Healthcare has seen some of the most life-changing applications. Surgeons can get 3D printed models of a patient's organs made from their CT scans to plan complex operations. We're seeing 3D printed prosthetic limbs that are perfectly fitted and can be highly customized. It's truly personalizing medicine in ways that improve people's lives dramatically. Section 7. The future is printing. What's next for this magic? So, where is all this heading? Well, one really exciting idea is distributed manufacturing. Imagine instead of giant factories churning out millions of parts that then get shipped all over the world, you have smaller, local, 3D printing hubs. If you need a part, the digital file is sent to the nearest printer, and it's made right there, when you need it. This could massively reduce shipping costs, cut down on emissions, and make supply chains much more resilient. Then there's the mind-bending world of smart materials. We're talking about 3D printing objects with materials that can do more than just sit there. Imagine printing something that can change its shape when heated or when an electric current is applied. Some researchers are even working on 3D printed materials that can repair themselves if they get damaged. And this one sounds like pure science fiction, but it's happening. Bioprinting. Scientists are using modified 3D printers to print structures using living cells and biological materials. The potential to save lives and revolutionize medicine is just staggering. Section 8, Making, Remaking, and What We've Learned. So, we've seen how 3D printing has grown up, haven't we? It's journeyed from being a niche tool for making simple models in a lab, to a powerful manufacturing method creating complex functional parts used in almost every industry you can think of. The core idea of building layer by layer has unlocked so much potential, allowing us to create things in ways our parents could only have dreamed of. It's important to remember that 3D printing is, at its heart, a tool. What makes it truly revolutionary is how it empowers people, engineers, designers, doctors, artists, hobbyists, everyone. It gives us the ability to turn ideas into physical reality much more directly and quickly than ever before. And the evolution is continuous. Every year, 3D printers get faster, more accurate, and capable of handling an even wider range of materials. The software that drives them gets smarter and easier to use. It's an incredibly exciting time to be a maker. And 3D printing is a huge part of that excitement.